Let's talk quickly about types of ions for ionic compounds. So there's going to be monoatomic, mono meaning one atom with a charge, and then there's going to be polyatomic, multiple atoms together that have an overall charge. So monoatomic metals, okay, those are going to be metals again, and metals, let me go back. Metals, again, are on the, which side of the periodic table? The left, right? So they're over here, group 1A, group 2A, and the transition metals. Metals are always going to be cations or positively charged. Nonmetals are going to be the anions or negatively charged, so those guys are negative. Make sure you know that most polyatomic ions are anions, so those are the negative ones again. And this is kind of a nice summary here. I did post this periodic table of ions in this folder on Schoology, so check that out. Make sure you know these ions, the polyatomic ones, okay? There are really only two positive ones, and ammonium is the one you'll see the most, NH4+, and then hydronium, H3O+. So those are the most common ones. Make sure you know these guys though, cold, and that's another flashcard thing you can study, okay? So let's talk about classes of ionic compounds and how to name ionic compounds from formulas. So there are really two categories here. There's a type 1, and then we'll talk about in a moment a type 2. Type 1 ionic compounds contain metals that only form one ion species, meaning they only have one charge always, okay? They're mostly in the group 1A alkali metals, group 2A alkaline earth metals, but there are a few in the transition metals, namely silver, okay? Silver is always +1, it's always Ag+. So how do we name these from formula? So the first thing we do, we name the metal. And the metal is always the first element, so this is a lot like the naming covalent compounds. We just name that very first symbol there. So in this example, Mg is the first element, magnesium, so we just call it magnesium, no changes. We name the second element, the nonmetal, by changing the suffix, just like we did in covalent compounds. So we add an IDE to chlorine here, so chlorine becomes chloride. And then finally, we just put them together. So here we got magnesium chloride, and it's as simple as that. No prefixes needed to indicate the number of chlorines here. We just say magnesium chloride. It's as simple as that. How do we write type 1 ionic compounds from a formula? I'm going to teach you a method, or remind you of a method hopefully, called the lift and switch, where given a formula, we can figure out the name. This is more important really for type 2, but we'll kind of run through this method real quick here with a type 1. So let's come up with a type 1 ionic compound. Let's do another magnesium one for simplicity's sake. We'll do magnesium, how about magnesium fluoride? So Mg, F2. Okay, so there's our compound. The lift and switch is simply take the subscript for each element. I'll start with F here. I lift and switch onto magnesium, and it becomes the charge. So this was the original charge when magnesium was an ion by itself. It was Mg plus 2. If I want to know F's charge, I say, all right, what was the subscript here on Mg? I lift it and I switch it. Since there was no number, I know it's a 1, right? So the charge on the nonmetal is -1. So F minus, there we go. Now, I don't really need to worry about this so much right now with type 1, but it's something we'll practice with type 2 a lot. So really just naming this from, let's clear this and go back to our formula. Mg F2. So really all we need to do here, guys, is say, all right, what's my metal? Magnesium. What's my nonmetal? Fluorine. I'm going to change it to fluoride. Done. Okay. Type 2. So type 2 ionic compounds are the ones where we got to do something a little bit different. Most type 2, or in fact all type 2 compounds, have at least 2 versions of the metal ions, right? So titanium here can be +3 or +4. Chromium can be +3 or +2. Iron +2 or +3. So to figure out which one we have, which type of metal ion we're dealing with, we do something, we add a number, a Roman numeral, okay? So type 2 ionic compounds are always going to be made from these metals that can come in multiple flavors, essentially. Okay, so let's practice. So let's come up with naming a type 2 ionic compound from a formula. So I'm going to say, let's do, how about something with copper? Let's do copper. What do you think? How about copper F? All right, so using another element that we already used. All right, so here's the formula, CuF, and I'm going to use that method that I used for the type 1 to figure out the name this time. Okay, because I have to really kind of figure out what copper do I have. Do I have the copper 1 or do I have the copper 2? So I'm going to say, all right, what's my subscript here? Well, there's no number, right? So I know it's a 1. So I lift and I switch, and this is going to be +1. So I know right now my flavor of copper was copper 1. So writing its name, I just write copper, and then I put 1 like that. Okay, so we got copper 1, and then fluorine is my element here. So I'm going to change that fluorine to what? Fluoride. And voila, I'm done. So here's another example of type 2 ionic compounds containing transition metals and multiple ions. So we got Fe2O3. If you do the lift and switch, right, the 3 goes on to Fe, the 2 goes on to O. Here we go, Fe +3 and O2 minus. I'm going to name the metal. What am I going to name the metal, guys? It's going to be iron 3. Okay, so the Roman numeral always corresponds to the charge on the metal, never on the non-metal. And then finally, I'm going to change oxygen to oxide. I put it together, and I get iron 3 oxide. All right, so let's do now writing the ionic type 2 ionic compound formula from the name. So I'll give you one. What's another good transition metal? Let's do cobalt. Okay, so here's a name, cobalt, and I'm going to put Roman numeral 2, and I'm going to say cobalt 2 iodide. Okay, so maybe pause the video for a second and practice this. What do you think the formula is going to be for cobalt 2 iodide? All right, guys, here we go. Here's the answer. So cobalt 2, that tells me something. That tells me, all right, and I'm going to start with the ions here. That would be cobalt +2, right? And then I, capital I, is going to be in group 7A, the halogens. So I know its charge is -1, right? So here I can do the swap and drop, and that will get me the formula. So I know that the 1 here becomes the subscript for cobalt, so it's just 1 cobalt. And then the 2 goes on to the subscript for I. So I get cobalt, or CO, I2. And there's my formula. If you want to check your answer, do the lift and switch. See if you can get back the same charges, and if that makes sense to the name, the Roman numeral here. All right, a couple of special notes about polyatomic ions. These are going to be compounds when you're looking at these formulas, you're going to have at least 3 capital letters telling you that you have at least 3 atoms present in this formula. Now, it might just be 2 different types. Well, actually, I'm trying to think of an example. No, it won't be. You can always have at least 3 different elements in these polyatomic ions, maybe 4. And a lot of times, oxygen is present at the end of the formula. So let me give you an example. So let's say our polyatomic ionic compound is this guy, NaNO3. Okay, so we have 3 different elements here. Na is sodium, N is nitrogen, O is oxygen. The formula is set up just like this. Now the NO3 is our polyatomic ion here. Okay, he's the one that has a charge where we have multiple ions, an N and an O here with an overall charge. And then our Na is our metal, sodium, right? So you can say, all right, Na, I know something about Na. It's in group 1A. It's an alkali metal. It's going to be a +1 charge. I only have one of those guys with this whole thing, one of those NO3 things. So that can tell me some information, right? If I only need one NO3 to cancel out the charge with the positive one from Na, that must mean this is -1, right? So I said at the beginning that most polyatomic ions are anions. Here's an example of one, okay? So we would call this thing, what's the name? It's sodium. And then polyatomic ions are really easy to name because you just name that ion. So it's sodium nitrate. Nitrate, by the way, guys, is going to be a very common ion that you'll see all year long, okay? So there we go. Let's do one more just so you can see it. Maybe we'll do a type 2 polyatomic ionic compound. So let's go back to copper. Cu. And then let's put copper with OH. Make it like that. Okay? Alright, so again, I have 3 capital letters, Cu or C for the copper, O and H. So I know I have a polyatomic ion somewhere in there. When you see parentheses like this and then some letters inside, that can pretty much tell you right there you're looking at your polyatomic ion right there. So this is hydroxide. If I do my lift and switch, I know that this was copper 2. So I'm writing the name here. And then hydroxide, if I did the lift and switch from the copper, I know it was -1. So hydroxide, you know, that's just telling me the charge on hydroxide, but I just name the polyatomic ion when I'm writing the name. Hydroxide. There you go. Alright guys, so what should you have learned here? You should have learned how to distinguish between covalent and ionic compounds, both by their names and their formulas. You should have learned how to write the name and formula for covalent compounds, how to identify the name and formula of monoatomic versus polyatomic ions, and then finally how to write the name and formula for type 1 and type 2 ionic compounds, and note those differences at the end there too with the polyatomic ions. Hope that was helpful.